morning everyone, my name is Harshavardhan. Today my subject was digital circuits and design. Topic was the building the simple arithmetic operations, addition, subtraction and multiplication using the Verillog code, and my branch was ECE department. Today introduction of the Verillog arithmetic. In this presentation covers the development of simple arithmetic operations, addition, subtraction and multiplication using Verillog. We will learn the essential Verillog constructs module in design and testing techniques and required to implement these operations efficiently. Basic Verillog for arithmetic. Verillog is a hardware description language used to module digital circuits. It allows designer to describe hardware behavior and structure using code, which can later it synthesized into actual circuits to FCGS or ASIC. Arithmetic operations such as addition, subtraction and multiplications are essential in digital systems like processors and signal processors. In Verilog, these operations can be implemented using operations like plus means addition, minus it means the subtraction, and star symbol is used to multiplication. Inputs and outputs are defined using the module keyword, and the data type used is typical reg or wire. Arithmetic module in Verilog help in understanding how mathematically functions are executed at the hardware level through combination reg or wire. Arithmetic modules or Verilog help in understanding how mathematically functions are executed in the hardware level through the combinational logics. The next was the overview of the language and structure. Verilog is a hardware description language used to module electronic systems. It is used to modules has building blocks with ports for input and output. Understanding the basic syntax and structure of Verilog code is critical for designing any arithmetic operation efficiently. And the data types are and operations in Verilog code. Verilog code supports the very several data types like wire and range. Arithmetic operations rely on the operations such as addition means positive and slash means negative, and which performs addition, subtraction and multiplication respectively. Selecting the correct data type ensures the proper operation behavior and synthesis result. Designing modules and ports. Modules encapsulate functional in Verilog. Designing inputs and outputs as module ports allows reuse the testing. Proper port declaration and connection are essential for creating reusable arithmetic units or integrating them into large designs. Implementation of addition. In using the 4-bit adder and Verilog code of the 4-bit adder. Module adder means we have the adder is the name of the module which you have keeping. The inputs are the A, B and sum. Input we have the 0 to 3. It means the 4 inputs are A and B. The output is the inputs are sum is 0 to 4. That we are assigning the sum is equals to A plus B. This is addition operation which is used to and at last you have to the end module. The output will be the output has been next, which will add the A and A plus B, which you have inputted the A values and B values in the place. You will come the output. Example, we will keep the A is equals to 3 and B is equals to 4. The output will be sum is equals to A plus B, 3 plus 4 is equals to 7. And this is the implementation of the addition. And creating a simple adder module. Basic adder module is adds into two input values and output the sum. The sum module plus operator within in an always block or assign statement. The design must consider the bit width to handle the expected input size and output correctly. Creating a simple adder module is a very creating of anything away handling carry bits in Binary addition carry bits occurs when some exceed but capacity. Managing carry by designing a carry lock or ripple carry adder improves the accuracy and performance handling. Carry ensures the result remain correct across multi-bit operation. Testing the addition with the two best test benches. Test benches simulates the add module and to verify the correct function before hardware implementation. They generate input and simulation and check the outputs against the expected result using automated test benches help they identify logic errors or ensure the adder performance reliably across all the input combinations. Implementation of the subtraction. The Verillog code we have using the 4-bit same the code which I have used in the addition 4-bit, and there you have done the addition and now you have to do the subtractor. This is the arithmetic operations that having the addition, subtraction and multiplication, and other sum also there. We have to doing only three operations of addition, multiplication and subtraction. Now we have completed. Now first one was the addition. Now we are doing the subtraction. The subtraction means we have to do slash dash symbol between the a minus b. You have to check the now we have to see the Verillog code. The Verillog code for 4-bit subtractor is having same. You have to keep module, and the module after you have to keep the file name of which you have saved that subtractor, and you have to give the inputs which I have used in the code. They are a comma b and difference. Difference means they are using the output value to show us the input are 0 to 3. A comma b, these are inputs a and b which are using 0 to 3, and outputs is 0 to 4 which you are this assign has the difference. Assigning diff is equals to a minus b. This is subtraction operation, and at last you have the end module. Here you have the same in the addition a plus a 3 plus 4 is equal to 7. Same here also 3 minus 4 is equal to output will be 1, which you are not showing the symbols of minus 1 or anything. You have to only showing the 3 minus 4 is equals to 1. Here subtraction will show the output 3 minus 1 is equals to 1. The next was designing a subtractor module. How to design a subtractor module we have to explain now. A subtractor module calculates the difference between two values using the minus operator. It requires careful width management for inputs and outputs. The design may be include logic to handle the unsigned or signed arithmetic depending on the system needs. It means the difference between we have using the two operations we have that are which is not assigned or assigned. You have to be they are the arithmetic depending on the system needs which you have to note. The managing and borrow bits. The managing and the borrow bits has the carry bits. The managing of borrow bits just has addition has carry bit, and subtraction involves borrow bits. When I forgot to explain this, addition means you have to bits will has carry the bits. The subtraction involves the borrowing bits, but borrowing bit means you have to taking the another bits into this including then when the minimized is smaller than the subtrahend. The handling borrow with the proper logic ensures accurate subtraction, result in the multi-bit operations, preventing the errors in the digital circuits. That means when we are doing subtraction in using in Verillog code, we have to do subtract from the we have borrowing the number from the another one which you have. This is the to giving the accurate answer or result. Anything that you have to do the perfectly. The verifying subtraction functionality. The subtraction modules are through testing with various input pairs using test benches. Verification includes checking borrow, propagation, and result correctness. Simulate tools to enable the designers to validate module behavior before the development. The implementation of the multiplication. Same you have seeing the two addition and subtraction as the same. Now we have to using the multiplication. The multiplication means we have doing the star symbol to do the multiplication. Now we have see Verillog code for 4-bit. This is also same bit we have using the 4-bit multiplier. Same file name you have to keep the multiplier and use the same starting module multiplier a comma b, which are inputs of same doing addition subtraction. Here also same a b and product. There you have first one has the addition sum and second one has the difference. Now we are using product. These are the output values which are you can give anything which you show giving the inputs. The input same 0 to 3 a comma b are the inputs. Output are 0 to 7 which we have increased. Now 0 to 7 we are increasing the product. Now assigning product was a into b. The a star b also star also called as multiplication symbol. It is a multiplication operation. At last we are doing the end model. Example, you have to take the same as the 3 and input a is equals to 3 and b is equals to 4. The output will be the a 3 into 4 is equals to 12, which is the output of the implementation of the multiplication. Same, now we have to do the same code which is using the same addition and multiplication. Now we have to see the building a multiplier module. How to build a multiplier module. The multiplication in Verillog typically uses the operator or combinational logic, or designing an efficient multiplier requires accounting for input sizes and the described precision. The module outputs that are product and often requiring double the input bit width. Optimizing multiplication logic. Here we are using the optimizing multiplication logic means optimizing means you have to converting the performance of the multiplication. Now we have to see how to optimizing. The multiplier performance can be enhanced using the techniques like shift and add, both all algorithm or calculators, or optimization focus on the reducing latency and resources usage, which is critical in hardware design to complex systems. Simulation and the validation of results. We have seen the simulation and validation result of the multiplication. Now multiplication module must be simulated across the input ranges to confirm the operational accuracy. Validation helps it detect the overflow conditions and verify the timing construction well constructed. The test benches improve the confidence in the multiplier and the reliability. The conclusion was the implementing these arithmetic operations in Verilog requires understanding language fundamentals, designing modules, components, test and through testing and proper handling of carry and borrow bits in its correctness in addition and subtraction, while optimizing multipliers design improve performance. Simulate and validation are crucial steps to before hardware development to guarantee reliable arithmetic functionality. We can conclude that these are we have seen the both implementation and result of the both addition, multiplication and subtraction. These are the three codes which we have seen in before slides. They are having the Verilog and Verilog code of the addition, multiplication, subtraction. In addition we have done the same a plus b, and subtraction we have done the a minus b, and multiplication we have do the a into b. Now we can see you can conclude that the three are doing the you can see that the curve brackets having the a comma b and product. You can use any of the variables which you can having variables at a or b c d, anything which you can use in the flower brackets, and the product is not use that only product for output value. You can use the product value as a mul or anything which you can use to show the output. These are the example of the output values. The input having the 3 is to 0, you can increase that 0 we are using only 4 bit, that's why we are using the 4 to 3 input. On the output will be you can increase it 0 to 7. This is the output. You can show that the which, and the carefully you can have to see that you have to use which variable that are using in starting, and that and which that is variable has to end at the end also. Don't use another variables in the middle of the program which you are using a into b which are keep in the curly brackets. You could not use the b into a which do not be executed in the program. You can show the errors of the program which you have shown in the I can these are the program which you have shown the addition, multiplication and subtraction. These are the programs which you have completed. This is the presentation of the my arithmetic operations of addition, multiplication and subtraction. Thank you.